So just an introduction to the topic. Nutritional anemia is described as a low oxygen carrying capacity due to decreased availability of hemoglobin. Hemoglobin works with iron in your red blood cells. It binds the oxygen to the red blood cells, and through the blood it carries that oxygen to your body tissues where it can be used. But when there's a lack of hemoglobin, that binding process is interfered with, and we don't get to utilize all of the oxygen that we're breathing in. So naturally, these symptoms include a decrease in aerobic capacity, decrease in endurance, and overall fatigue. And so specifically today, when we're talking about athletes, that's a huge problem. This affects 16 to 21% of premenopausal women. 1.7% of those are at a serious health risk. And on top of that, physical activity decreases. It alters the level of hemoglobin in the long and the short term. So our study, we took 13 female athletes from Palm Beach Atlantic University. We did some different tests on 2 different days over the course of 5 weeks. On the first day of testing, when each athlete came in, their height and weight were recorded, they signed consent forms, and then we carried on with instructions for a nutrition analysis, which I'll explain more later. We did hemoglobin concentration tests and a body composition test. For the nutrition analysis, they were asked to track their total food intake over the course of 3 non-consecutive days. The non-consecutive days are in order to combat an inaccurate reading of their overall intake, whereas if it were 3 really good days in a row or 3 really unhealthy days in a row, the non-consecutive days helps get an accurate reading of how they're eating over the course of just their normal habits. The hemoglobin concentration test was done through a finger prick. We just got 2 drops of blood, and that was enough to tell through our HemoQ 203 autoanalyzer. This measured the grams of hemoglobin per deciliter of blood. Then our body composition was measured through the COSMED bod pod. This is one of 2 in South Florida, so we're really thankful to have this in our lab. And this works through air displacement and known densities of muscle mass and non-muscle mass. So when the subject goes into the bod pod, the air that is displaced, along with the known densities of fat and non-fat, the machine is very good at calculating body composition. On the second day that the athletes came in for testing, they did a second round of blood testing. This was a metabolic panel that tested for 14 different minerals and proteins that I'll show later. It was a little bit more blood than the 2 drops. It was less than 1 milliliter. And then the nutrition analysis, when we received that information back, we input all of that data into the ESHA software for nutrition analyses, and this measured over 50 micro and macronutrients, but we focused on these 7: B6, B12, folate, vitamin A, iron, magnesium, and zinc. Because hemoglobin is one of the strongest indicators for anemia, all of our blood panel and nutrition data was compared to their hemoglobin levels to find correlations and indicators for anemia. So on this chart, you can see our subject characteristics. The subjects were primarily freshmen and sophomores, all of healthy weight and BMI. I would like to point out the mean hemoglobin count for our subjects was 12.3. A healthy hemoglobin is roughly 13.5. Anything less than 12 is considered anemic. And so overall, we did have a pretty low hemoglobin count for these athletes. Particularly, only 2 had a strong, healthy hemoglobin level. Like I previously mentioned, we primarily looked at these nutrients. As you can see, the mean values are pretty low. None of our athletes were getting less than 2 2.5 to 3 meals a day. So it wasn't a matter of them being underfed, which is interesting. But I'll mention that a little bit more in a minute. So this is the data from our comprehensive blood panel. This test was completed on the second day of testing. All of these values, as you can see, are within the healthy range, none of which showed any statistically significant correlation to hemoglobin. What we did find, though, was that B12 shows a positive, strong correlation to hemoglobin. So as the chart states, the hemoglobin count in relation to their intake daily of B12 increased together. So the higher intake of B12 that these subjects were eating, the higher we saw their hemoglobin count. The next thing we found, this second graph shows the negative correlation between hemoglobin and vitamin A. What we saw is that the test subjects with lower hemoglobin levels tended to have higher vitamin A intake and vice versa, as you can see on the graph. These findings could simply be related to the primary components of each athlete's diet. We know that iron, which plays a big role in the formation of hemoglobin, that's primarily found in animal proteins. So it can be an assumption that an individual who eats a lot of animal products will have a higher hemoglobin count because of their iron intake. And we could say also for vitamin A that vitamin A is found in more vegetables, leafy greens, and so any test subject who eats a primarily plant-based diet may have higher vitamin A levels, but that's not always the case. One person or two people could eat the same amount of meat. One could have more vegetables in their diet than the other, and then hypothetically they could have the same hemoglobin levels and one could have more vitamin A. So it doesn't necessarily show causation. Other factors that we assumed could be playing a role in the data is societal pressures, especially as an athlete, to maintain a low BMI and a low weight. That can affect your nutritional intake. Also, the coastal geography that we live in, that adds a pressure to maintain a beach-ready body at any point in the year. Also high stress and just a busy collegiate schedule. I know even personally, sometimes I'll have a busy day and not have time to eat for 6 or 7 hours at a time. And I know especially for athletes, you have an especially busy schedule. For future research, an increased sample size is always desirable. We started with 13 and ended with 7 due to some trouble getting information back regarding the nutrition analysis. With that, I think it would be beneficial to format that collection process in order to get a better response from the subjects. And then lastly, I would love to measure the hemoglobin content as a baseline like we already did, but then also after vitamin supplementation. There are some of our sources. And I would love to take any questions. Kyle.
You might have said, but what sports did these females play?
I believe that's confidential.
Okay.
Anything else? Mm-hmm.
A couple questions. You might have mentioned this, but did you take the hemoglobin levels at several times during your study or just once?
Just once at the beginning. They came in twice. We took the hemoglobin on the first day of testing and then the second blood panel on the second day.
And my other question is, since you're testing females, did you make sure that they weren't on their cycle?
We did not, and that's definitely a part of it. That definitely affects the data for sure. Mm-hmm.
Did you take into account, did you consult with the coaches about what stage of training they're at? Because I'm sure if an athlete is going through more aerobic training, they might experience more fatigue and it might actually affect the iron levels and stuff like do that?
Good question. The coaches knew all about the study. I believe they were in preseason at this point. I'm not entirely sure how that affects what their aerobic activity was like during that time. So I don't exactly have data on that, but yeah. All right, well, thank you so much.